On the front of this paper that I've given you is your plain old periodic table, a few additions I have made to it. I've put squiggly lines around all the things that are diatomic. That will be really important, especially in the next chapter. And I've drawn a line to show where the lanthanide and actinide series fits in. That's easy. On the back, what you have, the very top, this is a reference sheet. You will be able to use this all year. You'll be able to use it on quizzes, tests, homework. You can sleep with it under your pillow. You can get it tattooed on your arm. You can get it laminated and pass it on to your kids. The top chart is a nice reminder if you've been struggling with, what ion does sodium make? Group 1 forms a +1 ion, group 2 forms a +2 ion, group 16 -2, group 17 -1. So that's just a helpful reminder. And then over to the side, aluminum and nitride form +3 and -3 respectively. The next chart there are all of those common metallic ions. The D block, tin, lead. So you've got that as a reference to know what ions they form. Below that are your polyatomic ions.
Dihydrogen phosphate.
Dihydrogen phosphate, permanganate, carbonate, hydrogen carbonate, all these. You're going to get real familiar with them. I used to make my chem students do a polyatomic ion quiz, and you had to memorize 20 of them, and you had to take it until you got 16 out of 20, and I gave up on that. In the real world, you're going to be using a reference, and honestly, by the end of this year, you're all going to know the nitrate ion when you say nitrate. Because you'll just have used it so much, you will have learned it. The stuff on the very bottom, the oxidation numbers and common acids, those we'll use in the future, but you're getting them now, so you can kind of ignore those for right now. So remember when I said that IDE was really important? Okay. I'd like you to draw your attention to the first row of the polyatomic ion chart, and I'd like you to draw your attention to near the bottom and find nitrate. And then I want to ask you some questions. So, this compound, Na3N, what is that? Care to name it? Sodium nitride, an IDE. Now, we have another compound. You have probably all consumed it in your lifetime. It's commonly used to cure pork products. If you've eaten ham or bacon, you have eaten this compound. This is a sodium ion paired with what other ion? Look at that chart. Nitrate ion. So this compound is sodium nitrate. Very different compounds. Only subtly different names. Now I'm about to make it even worse. Look down below the nitrate ion. So this compound is called what?
Sodium nitrite.
Sodium nitrite. Do you see where one might get confused?
Yeah.
Yes. So, you are always going to be very careful, and you're always going to know that whenever you see this IDE ending, you are talking about a monoatomic ion. Right? And occasionally you'll slip, and that's okay. Now, let's practice writing. We're not even going to talk yet about the difference between eights and ites and the polyatomic ions. But right now, I just want you to note how similar those three names are, and yet how different those compounds are. Okay? So right now, we're going to practice writing a couple of compounds using polyatomic ions. So let's do, oh, here's a favorite. Anybody have a water softener at home? A water softener system? Okay. Have you ever paid attention to what whichever parent maintains it, what they put in there other than salt? Okay. A lot of water softener systems use a chemical called potassium permanganate. Now, where on the periodic table is permanganate? It ain't. Ha! Permanganate. It ain't. It ain't. Never mind. So, potassium permanganate is a potassium ion, or some number of potassium ions, and some number of permanganate ions. Write the formula for the potassium ion. Write the formula for the permanganate ion. Where are you going to find your permanganate ion? This is now your ion Bible. This is the thing you will never be without. This is the thing you will read and love and learn and work with daily until, well, probably not. So find your permanganate ion. It's in the polyatomic ions.
MnO4 1
Good
minus.
job. MnO4 1 minus. Okay. Now, don't forget that this is a discrete unit. You cannot ever split it up. You cannot ever change any of the numbers or letters that are in there, because what we're saying is we have a manganese atom bound covalently to 4 oxygens. If you change this subscript, you no longer have your polyatomic ion. Okay, so you have to be careful. When you're learning, it's very often easiest if you put brackets around your polyatomics, because it kind of keeps them separate in your mind. When you go off to a college chemistry class, if you're still putting brackets around them all the time, you might get laughed at or pointed at or made fun of, but that's okay. So in this case, these charges are going to crisscross. And we have KMnO4. Okay? We don't actually need the ones, we know that. And because we don't need the ones, we really don't need the brackets. We can just write KMnO4. Okay? So, let's do another one that's similar to that. Let's do, oh, okay. So, let's do calcium carbonate. What's the symbol for what's the formula for the calcium ion? Ca2 plus. Find me the carbonate ion.
CO3 1 minus.
CO3 what?
CO3 2 minus.
2 minus. CO3 2 minus. Okay. That's a discrete entity. We cannot break it up. We cannot move it around. We can't lose that number. So we end up with Ca2, CO3 2 times. Well, guess what? Do we need the 2's there? No. That simplifies. So we can just write Ca, CO3. Okay. Not too bad, right? Okay. Let's practice one more of those, then we'll turn it on its head. Let's see. Oh, okay. Magnesium bromate. Magnesium bromate. I'll let you get a head start. Okay. So somebody I have not heard from, give me the formula for the magnesium ion. Okay. Yes, it is magnesium 2 plus. Okay. Somebody who I've not heard from. Let's see, you know who you are. I'm looking at a couple people in gray I haven't heard from, and a couple people in black I haven't heard from. All on the edges. Oh no, one in the middle. I haven't heard from you. So, what's the formula for the bromate ion? BrO3 1 minus. So, we're going to have those parentheses. Mg1, BrO3, 2 times. Okay? And of course this 1 we don't need, so we just write Mg BrO3 2 times. Now, if you write this is correct, right there, Mg BrO3 2 times. If you were to write this, you're essentially saying you've got a magnesium atom, a bromine atom, and 32 oxygens. Wrong. What if you were to do this? Let's see. Okay, I can multiply that out. Okay. Wrong! Because there, somebody tried to multiply the 3 by the 2, and, so now you've got a magnesium, a bromine, and 6 oxygen. No. Can't do it. So you have to keep this ion a discrete unit.
Could you have, like, magnesium Br2O6?
It's no. You cannot. No. So let's
sure?
No. Let's look at so let's look at this from a Lewis structure standpoint, because that's I think the clearest way to understand this. So what we're talking about is we have a magnesium ion, and remember we can draw a Lewis structure that shows an ion. And then we have the bromate ion. Let's see. And I believe 7, 6, 3. Okay, I'm probably gonna do the Lewis structure wrong, but just bear with me here. Well, we're gonna pretend that's correct. I'm not gonna take the time to figure it out right this instant. There's one bromate ion. Oops. There's another bromate ion. So you're talking about 2 individual entities. So you're not talking about something that's B2O6, because then you're saying that's a covalently bound thing or a ratio of ions. You were talking about 2 BrO3s. Does that make sense? You see why you can't do that any other way? Okay.